Hi everyone. In a world where the number of nuclear plants is growing, it is more important than ever to work on means that prevent and mitigate severe accidents and be one step ahead, anticipating post-crisis situations and ways to stabilize in the long term. So good afternoon everyone. I'm Adrien Leroyer. I work at EDF as a project manager, and I'm here with my business partner, Vincent Le Breton, from Veolia's Nuclear Solution business. We are here to present you the solutions that we are deploying on the French nuclear fleet, the UMTEC. So what is UMTEC? It stands for a French acronym. It's a French term that stands for Mobile Contaminated Water Treatment Unit. So the UMTEC is a product of three main partners and is the outcome of beautiful innovation, engineering, and human adventure. Vincent and I are here to present you, but if you want to address Marie-Pierre, which is just here, from Réel, you can ask questions at the end of the presentation in the room just next to us. So, I will briefly present to you the context and the genesis of the project, why we are doing UMTEC. Before I let Vincent go into more details on what this machine really is. So the outlines of the operating principles of this machine, a focus on the design of consumable cartridge, which are the heart of the decontamination process, and finally a presentation of the monitoring principles of this machine. And I will conclude finally. So first of all, some context about the UMTEC. So, the Fukushima nuclear accident put the world spotlight on the management of contaminated water following a nuclear severe accident. Minimizing the consequences necessitated the very quick and reactive development of water treatment systems, in which Veolia took an important part designing and commissioning. Back to France. So I'm representing EDF, the major operating industrial of nuclear power plants. And in France, the instruction of the fourth decennial periodic safety review took place in the light of these events and the light of the Fukushima accident. It has been brought a new approach to the handling of nuclear severe accidents by taking into account not only the possibility of radionuclides dissemination through gas dispersion, but also from contaminated water leakage in the underground. And such an approach led us to develop successive barriers to minimize the potential effects of such a catastrophe. I won't extend here on all of them, but one of these barriers is to treat and to remove the radionuclides from the water inside the reactor building. It's what UMTEC is made for. To achieve this goal, and to concretize the concept into an operational system, EDF partnered with Veolia, world leader in waste and water treatment, and with Réel, industrial nuclear equipment engineering specialist. So if we put this story into a timeline, this is what you'd get. It all started in 2020, and because of the French Nuclear Authority technical prescription in 2027, we had to have UMTEC ready for 2027. So it was quite a challenging project in terms of deadline since the beginning. After 3 years of studies, we are now reaching testing and design. UMTEC is now approaching the final stages of its development. Today, manufacturing is nearly complete, and the system is on track to begin acceptance testing in November. And it is scheduled to be delivered to EDF, the main customer, in summer 2026. So just as a customer, the main requirements, and that Vincent will go into much detail, so how we tackle these requirements. First, it had to be a mobile system deployable on any nuclear power plants in the French fleet. 900, 1300 or N4, it's the same machine for every nuclear power plant in France. It had to be deployed within 3 months. So it's a post-crisis machine in order to deal with such severe accidents. It had to meet some standards in terms of performance, decontamination ratio in 100 in 2 months, and about 1 million within 4 months. It was a closed loop process because we re-inject the water afterwards inside the reactor building, inside the process. It was designed to be able to treat highly contaminated water from up to 1 terabecquerel per liter. And it was to be compatible with current deploying operating standards for radiological dose levels for the workers. So Vincent, I will let you go on with the technical presentation.
So, hello everyone. I'll try to explain how it works. So the system principle is based on Veolia industrial water treatment technology and lessons learned from Fukushima. The contamination process relies on filtration and sorbent cartridges. So this is how it works. The contaminated water goes from the reactor building into the pre-treatment skid for temperature and pressure regulation. Then the regulated contaminated waters goes through the removable cartridges mounted on the treatment skid. First, upstream, the filtration cartridges, which will trap the suspended particles. And secondly, the adsorption cartridges downstream, which will trap the radioactive element soluble into the water. Then the water goes back to the reactor building. We have also a chemistry skid will control the pH and boron concentration. And at this point, and altogether, if we think about 2,000 cubic meters of contaminated water, the water will go through the system about 40 to 50 times during a period of 8 to 12 months. So this is the machine UMTEC. As you can see, there is 3 skids for the water process. So the pre-treatment skid, the reagent skid, and the main skid, which is the treatment skid, on which the cartridges will be mounted and dismounted thanks to the forklift. We also have the control station and the electrical distribution container. So one of the main important lessons learned from Fukushima was the need to monitor cartridges loading, obviously. And to do so, the UMTEC has integrated these requirements since the beginning. So if you look at the blue curve, this is the contamination ratio over time. That is the main requirement from EDF. So within 2 months, the decontamination ratio has to be up to 10. And this contamination ratio has to be to 1 million in less than 4 months. So 120 days after the UMTEC is running. If you look at the color curves, it's the radioactivity over time for different types of radionuclides. And all these data are from Veolia experience and databases built up over time in the industry. We also have a water sampling device so that we can control on a regular basis the chemistry of the water, and we can control that the contamination ratio is at the expectation. So the design of the treatment skid is quite simple. The idea is to be able to put the cartridges, which are consumable, and to remove them within a good level of safety and reliability. And obviously, it has to be compliant with the radioactivity levels and the transport constraints. So, many calculations have been performed, and the outcome is a system which is compliant with the standard operation of the industry. The limited dosimetry and is one of the main targets. So below 20 millisieverts per hour on contact and below 2 to 3 millisieverts per hour at 1 meter. So many computation as far as the dosimetry has been performed by the people involved in the project. And the outcome is a maximum of 100 operators required to run the machine over a period of 12 months. We also implement advanced safety features. Among them, we can list the lead shield protection for safety around the skids, the leak collection and re-injection system, which is very important if we have leaks, the surveillance camera for oversight and real-time monitoring. Of course, firefighting system and in case of emergency, and of course redundancy and power supply system, so that we are ensuring that the system will work 24/7. Then let's focus on the cartridges advanced design, which is the heart of the system and which is from the Veolia engineering. So as you can see, we have 3 types of cartridges design. The upstream filter, so on the left, so the contaminated waters goes through the filters, and on the right we have the sorbent cartridges. The cartridge at the right, extreme right, is similar to the one we have in Fukushima. The annular cartridge in the middle has been developed specifically for the UMTEC project. This annular cartridge is able to handle very high contamination because we have a distribution of the water along the cartridge. It allows a much better distribution of the contaminated water, and it avoids hotspots. So we have a short video which shows how it works. So the filtration, it's the annular cartridge on which we can see the different level, and then the simple cartridge, which is going to be used at the end of the process. I can relaunch it once. Yeah. So the first one is the filtration. Second one is the annular sorbent cartridge, and the last one is the simple sorbent cartridge. This one is the simplest design. So as you can see, the final design of the cartridge is the result of numerous sizing calculation and iteration to find the best technical compromise. By the way, it's it's a masterpiece in terms of manufacturing, as you can see on the picture on the right, thanks to our colleagues from Real. Among the many design parameters, most important are the weight, so 12-ton maximum load for handling, the pressure inside, so pressure drop, and also the thermal constraints, as well as the ventilation and the constraints. Once the cartridge is loaded, we have to open up the cartridge so that ventilation is possible. And one of the most important thing also is the filling and emptying function and the interfacing with the treatment skid. And for that, we have developed a specific connection, automatic connection, to avoid any leakage and to make this easy for the operators. And last but not least, the industrialization process for mass production, because we are manufacturing around more than hundreds of these cartridges. Control and monitoring. So a team of 2 operators will be in charge of operating the system 24/7. The control station will be in constant communication with the forklift, which will handle the cartridges. And thanks to an intuitive INC system, management will be straightforward. It's quite simple to use. Then we have a second tool, a digital driving assistant tool, which has been designed to manage the replacement of the cartridges. And this is one of the key things of the project. And this has been developed by VNS people, by the way. So this digital twin collects the process data and calculates in advance the appropriate time to change the cartridges. The main objective of this tool is also to obviously optimize the use of the cartridges and the replacement frequency in order to achieve the target of contamination over time. The combination of those 2 management tools will clearly ensure the performance and the ability to the operator to maintain a very high level of safety and reliability. So, to sum up, these are the key technical challenges we overcome to meet with EDF requirements. First, the performance. So we're going to treat between 1,500 and 200,000 cubic meter of water with the very high level of contamination. As I said, we have those 2 decontamination factor of 100 in 2 months and 1 million in 4 months. And the dosimetry requirements so that something like 100 operators over 1 year will be required to operate the machine. So second one is the modularity. So the UMTEC system is around 20 containers, standard containers, transportable by trucks, and the installation and commissioning is expected to be in less than 3 months. We have the forklift to handle the cartridges, and we have the electrical power, which is something quite reasonable. And finally, the operability. So as I presented, the 2 management tools and the sensors and all the parameters that we're going to monitor all the time in real time to provide a good level of safety and reliability over the time. So this is, I let Adrien to conclude.
Yes, so just to tell you that we are very proud of what has been achieved. and accomplished so far, designing and manufacturing the UMTEC in such a short amount of time with a strong French industrial partnership with Veolia, with Réel, and drawing from Fukushima experience. But you know, designing and manufacturing and commissioning the UMTEC are not the only challenges to address. If we have a step back and we take a step back on why we are doing this, the approach to severe accidents so far has been to prevent and mitigate the effects with a pretty short-term view. With the UMTEC, we go one step further on the post-crisis situation, where the goal is not only to maintain confinement at all costs, but to think of the future and stabilize the long-term situation by considering the population going back safely, going back home, and safely drink water from the tap. So that's what UMTEC is for, and so let's meet in 2026 for the final delivery and 2027 for the final deadline we saw with the French Nuclear Safety Authority. Thank you for your attention.
By the way, if you want to learn more about Veolia nuclear solution, come and see us at our booth H30. Thank you.